Right, today we've got a pretty short and sweet lesson. If you took college algebra, we did almost this exact same section in that course. So we're talking about variation and focusing on three different types. There's direct variation, where that means, as one variable gets bigger, the other one gets bigger as well by the same ratio. Inverse variation is when, as one of the variables is getting bigger, the other is getting smaller by the same ratio. And then joint variation is when we have more than two variables that are related. And you can have joint variation that involves both direct and inverse, which you'll see in the examples that we're going to do. So these are the three formulas that we're going to be using depending on which type or types of variation we have. K in all of them is called the constant of proportionality. And always that's what we're going to need to find first, because once we know that number that is the constant ratio, that's what's going to help us to answer the question. Okay, so here's example 1, and you can pause the video because it might take you a minute to write it down. So pause it so that you can do that, and then unpause so that we can solve. So in this case, it has the keywords is inversely proportional to, which means that we're going to be using inverse variation. For some reason here, I clicked on to use red and it's still showing up in black, which is very odd. Oh well, I guess we won't be using different colors today. So if we're using inverse variation, that means we're going to use this formula. And our two variables in this case are revolutions per minute and the number of teeth in the gear. So we could say that the revolutions per minute is inversely proportional to the number of teeth. So it would look like this. So R equals K divided by T. So in this case, a gear with 48 teeth, so that means 48 goes on the bottom. K is what we're figuring out, and that has 40 revolutions per minute. So as I said earlier, our first objective in these types of problems is to solve for K. So in this case, very easy to do. We just simply multiply both sides by 48 to get K alone, and K equals 1,920. This is like our intermediate step. You have to know K in order to be able to figure out what one variable is based on the other. So now it says, what is the speed of a gear with 64 teeth? So that means R has to equal 1920, because that's our constant of proportionality. Constant meaning it's going to be the same for any amount. And then we put 64 down in the bottom. So then we take 1920, divide it by 64, and we come up with our final answer. Oh, the pen is really going crazy today. Sorry about that. 30 revolutions per minute. All right, I'm going to do another example. So here we have a problem involving horizontal beams, and this one we have joint variation. It says the load L that a horizontal beam can safely support varies jointly as its width and the square of its depth. If a beam with a width of 4 inches and depth 12 inches can safely support up to 400 pounds, how many pounds can a beam of the same length that has a width of 6 inches and a depth of 6 inches be expected to support? So here we have joint variation, which means we're going to have multiple variables going on. So it says the load L varies jointly. So L equals, And then joint variation is when we've got multiples here. But in this case, it varies jointly as the width. So we'll use W for that. And then it says the square of its depth. So be careful. You can't just put D for depth. It's the square of its depth. So D squared there. So then in the next sentence, they give us some values. It says width 4, depth 12 can safely support 400. So the load is 400. K is what we're trying to find. The width is 4 and the depth is 12. So then 12 squared is 144, and so then 4 times 144 gives us 576. So now we've got 400 equals 576K. And so we would divide then in order to find our value for K. And here, when we do that, it's not going to come out to a nice integer value. So just be careful, and I know we've talked about this before. I know I talk about this in Algebra 2 as well, but you want to use that second answer button on your calculator. You don't really want to round this guy. So here's our K value. Now we need to figure out how many pounds the beam of the same length can support. So the length is what's staying constant because that wasn't even in our formula at all. But now width is 6th and depth is 6th. So L is what we're trying to find. We now know K. And if it's easier for you, like if you just aren't good with the second answer button, you could leave it as 400 over 576 or the reduced equivalent. If you leave it as a fraction, that would work as well. But either way, we've got K now times 6 squared. So really, that's 6 cubed. And if we want to do that in an easier fashion. So that means that we're going to take our second answer button, the 0.694, and we're going to multiply it now by 6 cubed, which is 216. And what do you know? It actually comes out very nicely for us at 150 pounds. All right, believe it or not, we actually only have one more. So let me type that out. All right, so here's the last one, and it's not a real life situation, so not quite as many words to deal with, but we do have a lot more variables going on in this one. So with this variation, it says y varies jointly as m and the square of n. So y varies jointly as m and the square of n, and inversely as p. So inversely just means, it goes in the denominator. So p goes down here. Okay, so this is our formula that relates all of the variables. Now they give us our original values. So it says y is 15 when m is 2, n is 1, and p is 6. Okay, so we need to use this in order to find our k value. So of course 1 squared is 1, so I've got 2k divided by 6, which reduces to k over 3. And then I can easily get k alone by multiplying both sides by 3. So that gives us k equals 45. Again, once I have my k, then I go back in and use the second set of variables that are given to me. It says find y, so y is what I'm looking for this time. I now know that k is 45, and it says when m is 3, n is 4, and p is 10. So then we just have to simplify that. So exponents first, so 4 squared is 16. So then I've got 45 times 3 times 16, which gives me 2,160. And then dividing by 10 just chops off the 0 on the end. So that gives me 216 for my final value. All right, homework in this section is pretty short as well. I don't think you'll have a ton of trouble with it. And so I think that's it.